Hello everybody, my name is Mina Dimova and I'm a staff software engineer at ARM. Today our topic is moving the gym to your living room with body pose tracking on your smart TV, and I'm going to show you our fitness application. Our demo has been motivated by two emerging trends. The first one is home fitness, and here you can see some of the headlines outlining the added flexibility and increased demand for people working out anywhere and anytime. Increased demand for plans and programs and remote personal training. And on the right you can see also increasing sales of home gym equipment. The second emerging trend is the increased presence of cameras in smart TVs. And here on the slide you can see some of the examples. In China, almost half of high-tier TVs in China have now an integrated camera. And once you have the camera, you can start thinking of other interesting applications you can build using it. Here is an overview of our application. We want to estimate and continuously track the body position of the user. And we are using a convolutional neural network to do that. Then we want to compare this body position against the reference body position of a fitness instructor and provide some feedback. And ideally we see this as an application targeting smart TVs, but it can be really running on any other ARM-based platform. In our application we are using BlazePose models developed by Google. It consists of two convolutional neural networks, a detector locating the person in the frame, and a landmarks model which finds the 33 key points you see on the left. For the first frame we have to run both the detector and the landmark model, but in the consecutive frames we can run only the landmark models. Here you can see how our pipeline looks like. We start with the image from the camera stream, which we then resize and normalize, and we feed into the BlazePose detection model. Out of the BlazePose detection model, we get the detection boxes and we perform few additional operations such as crop, pad and rotate to prepare the image for inference with the BlazePose landmark model. Out of the BlazePose landmark model, we get XYZ coordinates as well as presence and visibility, and we project the coordinates on the original image. And finally, we perform a search and score between the data from the user and the data from the instructor. As mentioned before, in consecutive frames we can skip the detection model and only run the landmark model and reuse information from the previous frame to find the detection boxes. And here is how our application looks like on low-end Android smartphone. We chose low-end Android smartphone because we think it closely approximate the existing hardware in high-end smart TVs. On the left side you can see the instructor performing the exercise, and on the right side is the user following the same exercise. Here we have a choice of 4 different exercises as well as different resolutions and a choice between different inference engines. One is TF Lite with GPU delegate and the other one is XNN pack. Here are some challenging poses, but BlazePose is doing an excellent job. XNN pack is running on Cortex CPUs and the GPU delegate is running on Mali GPU. On a high-end Android smartphone, you can easily achieve real-time performance. Here we are demonstrating on a phone that was released 2 years ago, and you can see there is no problem achieving real-time performance. Here you can see a closer look of some of the results we've got with BlazePose. And here a few more. Here are some of the tools and libraries developed by ARM to help you develop your machine learning application. On the left side you have ARM Mobile Studio, which will help you profile your application and find the bottlenecks for optimizations. And on the right you have ARMNN and also ARM Compute Library, helping you do inference on ARM platforms. Also check MediaPipe by Google, which can help you build your ML solutions. And finally, here are some results on a high-end Android phone and on a low-end Android phone, already a couple of years old, using the TF Lite benchmarking tool running the BlazePose detection network. And here is the landmarks network. Again, best performance is achieved in this case using the TF Lite GPU delegate with OpenCL. And moving forward, we see smart TVs being the center of immersive experiences in your living room with their large screens and high resolutions. We see more machine learning applications coming to smart TVs and home devices in general, and an increased camera presence, possibly depth sensors in future. Existing body estimation convolutional neural networks show excellent results and provide opportunity for fitness applications and interactive gaming. If you want to learn more, please check ARM community, where you can find blogs on ARM technology and applications, as well as one on the topic we've just covered. I hope you found this useful and interesting. Thank you very much for watching.